So for the remainder of class, you're going to be working on your cross-section projects. If you emailed me within the last 24 hours, I probably haven't gotten back to your project. So once I'm done whatever this, I will make sure you guys have your prompt. Some of you already have your prompts, but you don't need further. But just a reminder that the volume of the solid created with various cross-sections is just simply integrating the area of those cross-sections. Area of the cross-section. So your formula will change depending upon what your shape is. If you have a square, obviously you're going to be integrating side square. If you have semicircles, pi over 8 sine squared. So your formula is going to change depending upon which prompt you have. Alright, now just a reminder, in case we have lost our knowledge of cross-sections between last class and today. Let's say that this is the region that I'm working with, where I have y equals 2x squared minus 4. And that this is, oh wait, sorry, that's the wrong one. Y equals x squared minus 4. And let's just say that our line is 2x. Okay, so this is the region that I'm working with. Then again, for your cross-section project, you're going to create 7 of those cross-sections. So you're going to draw your region, your base here. Then you're actually going to cut out of whatever materials you're using those shapes that are coming out of your board. So let's just suppose I have equilateral triangles. So I'm going to go and draw in a few of my equilateral triangles. And as you can see, depending upon where you are on your graph, that's going to affect the size of your equilateral triangles. So I'm going to actually find these shapes and cut them out. Alright, now, depending upon what shape you have, it might be easier to cut out some shapes rather than others. Squares, I trust you guys can take a ruler, measure it, and create a square that has perpendicular sides. Same thing with rectangles. If you have a semicircle, so let's say we have a semicircle on here. You're going to want to, remember this is your diameter, so your radius is going to be just half that. And then please use a compass to actually create that nice part. I do have compasses here for you for your convenience. Or you could always just use a piece of string if you're at home and draw it. So let's see, semicircles. Isosceles right triangles aren't too bad either. Because again, isosceles right triangle, whatever this length is also going to be your base. So once you, again, can use a ruler, measure that, draw your line, and then make sure it's perpendicular. Okay, that one's not too bad. I do want to show you guys equilateral triangles, though, in case you get that as a prompt. So the easiest way to do your equilateral triangle is using a compass, or you can even do it with just a ruler. I think it's easier with the compass. But let's suppose I'm trying to do this one here. Alright, so I'm going to set my compass to be this distance here. Ooh, that's pretty good. Alright. I want to rotate. There we go. Okay. So I want to make sure that I start off with that correct distance. Alright, so now this is the distance. Thank you. I never expected that to happen again. So this is the length of the one-side equilateral triangle. Now I know that my other sides need to be the same, but we want to make sure it's actually equilateral, not some isosceles looking thing. So if you take your compass here and just set it on one edge, and then do kind of a little arc, and then same thing on your other side, then that's going to give you those other two sides. Okay. So the compass will make your life a lot easier rather than constantly guessing how far it needs to go. Now you can do the same idea with the ruler, where you take your ruler. Sorry, the ruler's not so easy to work with. Where you take your ruler and measure and say, okay, well this is 1 and whatever that marking is, and then you're going to take your ruler and you can rotate that around. Again, same idea of using that to kind of create the arcs on either side. So if you're doing this at home and you don't have your compass, you can mimic the same idea with your ruler, where you're just kind of making those little arcs. And it doesn't have to be perfect, but if I get out a ruler measuring your cross sections, it should be relatively close, that all the sides are pretty close to each other. But that's, I think, the easiest way to do your equilateral triangle. Questions with that? Okay. And then remember, guys, as you're setting up your integral, so for equilateral triangle, I know that it is root 3/4 integral of my side squared, and for this one I'm doing dx. My side is this entire length here, and so if we're going with respect to x, that's always top minus bottom. If I'm going with respect to y, then it's going to be right minus left. So it just depends on which prompt you get. So for this one, my side would be my top function, which is the 2x. My side would be my top function, 2x, minus my bottom function here, which is the x squared minus 4. The other thing I want to caution you with is when you go to do your integral by hand. So if I take my side here, throw it into my equation. So I have 2x minus x squared plus 4. I saw a lot of people last class were trying to just do power rule, where they added one and said, okay, it's just this quantity raised to the third power divided by 3. Notice we have a lot more than just x happening here, so you can't just do power rule. You'd have to either do u sub, but I don't think u sub is going to be beneficial for this. Or, honestly, probably the best thing to do would be actually take this, FOIL it out, and then when you get your individual terms, integrate that. So just make sure that you are doing your integral correctly. Check with your shoulder or with your partner to make sure that you are evaluating correctly. Also, use your calculator to make sure you've done it correctly. Now, on your project, you will be showing the steps. I want to see your antiderivative. I want to see it plugged in. And then you can use your calculator to help you simplify. But I should see each step of doing of distributing it or foiling it out, doing your antiderivative, substituting in those bounds, and then the simplified version. So use your calculator to make sure you're doing it correctly. But you should not be using a calculator to get to your answer. Okay, those are, I think, all the things I want to point out. Yeah. Questions with that?
Wait, isn't it left to right?
No, if we're going with respect to y, you want right to left.
Oh,
Because you're going from the y.
If you need to go left here, one of the questions on the key, you told us to go right and left.
Yeah, right to left. Right minus left.
No, I mean, on one of the key, you told.
If you have you can take a look at a specific problem, Nick, but if we're going respect to y, I want to do right function minus left. So I'm going again from my y-axis out to my function. Alright, also guys, so when I send you your prompt, those of you that have already got it, you'll see that I say your group, yada yada, like group, I think you guys are like P5 or something like that. When you write your names on your project, also write what your group ID is. It just makes it easier for me to find the prompt amidst the millions of prompts that I have, rather than having to search to find it when I grade your project. Questions with any of that? Okay. So again, if you have not emailed me, go ahead and email me. Those that have recently emailed me, I'll make sure you get your prompt here in just a moment. I have up here for you. We've got a variety of items. We've got protractors, we've got compasses, we've got rulers, pencils, glue sticks. And if you happen to make it far enough, I do have a hot cookie gun. If you want to get the actual one. I do have blank computer paper, and guys, on the bottom of the black cart back there, not the two boxes that are in the middle because that has stuff in it, but anybody that had leftover cardboard stuff, we left it over there, and I've been grabbing paper boxes. So if you, that's up for grabs, basically. Is what I'm saying. Okay. Are there other questions?
Yeah.
Okay. So again, if you have not emailed